Introduction. Three-phase system is a economical way the bulk of power transmission over long distance and for division. Okay, the three-phase system consists to three-phase voltage source, two connection to three-phase load by means for the transformer and transmission line. Okay, two type of the connection, namely is delta and connection and star connection. Okay. Next, the unbalanced three-phase system is not a rating in the power transmission and distribution. Okay, cause of the unbalanced system, because the voltage source not same in magnitude, and the have angle different from the one phase to another. Next, star connection system is the three-phase four-wire system and is not most preferred to system of AC power transmission. Where for the transmission, data connection is generally used.
First and foremost, to find impedance Y, the formula is 10 plus J5, which is equal to 11.18 with an angle of 26.56 degree. For the inductive, we use the formula 2 pi FL, which L is equal to J5 ohm. So, which basically means 5 over 2 pi times 50 is equal to 15.92 milli. To search for line currents, for IA, we use VAN over ZY, which is 220 over 11.18 with an angle of 26.56 degree, which equals to 19.68 with an angle of negative 26.56 ampere. For IB, we put in the value from IA with an angle of negative 120 degree, which equals to 19.68 with an angle of negative 146.56 ampere. For IC, we put in the value from IA, but this time with an angle of positive 120 degree, which equals to 19.68 with an angle of 93.44 degree ampere. For line voltages, to find VAB, the equation is 220 to the root power of 3 with an angle of 30 degrees, and we'll get 381 with an angle of 30 degree voltage. For VBC, the answer will be 381 with an angle of negative 90 degree voltage. For VCA, 381 with an angle of negative 210 degree voltage, which means that BBC, the 30 degree angle is subtracted by 120, which equals to negative 90, and a further 120 to get 210 for VCA. Finally, for the load voltages, to find VAN, IA is multiplied with Z impedance Y, and we'll get 220 the voltage. For VBN, 220 with an angle of negative 120 degree voltage. For VCN, 220 with an angle of 120 degree voltage.
So for the result and discussion, the theoretical calculation method that were used for this project are matched circuit analysis. So from the calculation method, the value for the line current are IA is equal 19.68 with angle negative 26.56 degree ampere. For IB is 19.68 with angle negative 146.56 degree ampere. And for IC is 19.68 with angle 93.44 ampere. Next, the value for the line voltage are VAB is 381 with angle 30 degree volt. For VBC is 381 with angle negative 90 volt. And VCA is 381 with angle negative 210 degree volt. Additionally, the load voltage are VAN is equal to 220 with angle 0 degree volt, and for VBN is 220 with angle of negative 120 degree volt, and for VCN is 220 with angle 120 degree volt. Other than that, LT-SPICE software was used for the simulation part of this project. The result obtained for the value for the line current is IA is equal to 19.6747 with angle of negative 26.5692 degree ampere. For IB is equal to 19.6747 with angle of negative 146.56 degree ampere. And for IC is 19.6747 with angle 93.44 degree ampere. Moreover, the value for the load voltage of VAN is 220 with angle of 0 degree volt. For VBN is 220 with angle of negative 120 degree volt, and for VCN is 220 with angle 120 degree volt. These values were almost identical to the result gathered from the calculation methods. And furthermore, the percent error between the calculation and simulation for the value of line currents of IA, IB and IC is 0.03% plus the percent error for the value of load voltage of VAN, VBN and VCN is equal to 0%. In a nutshell, this slight error proved that LT-SPICE software was accurate and reliable in electrical circuit analysis.
Conclusion: we successfully measure and calculate based on theoretical and simulation formula. The value required to be calculated and simulated are the load voltage and the line current. For the calculation part and simulation part, the value is same. The percent error for load voltage are 0% and the error for line current are 0.03%. Lastly, the electrical circuit has been analyzed and valid through the calculation based on the theoretical and simulation formula. Future recommendation. Nowadays, the simulation and calculation formula of the electrical circuit is an important stage because to reduce the cost and to reduce of the damaged electrical component. For environment, the project, we get more accurate and better electrical circuit. We can analyze other simulation that can give accurate measure in the electrical circuit. In addition, electrical circuit can be improved with simple circuit design using the simulation. Finally, the project can be continued by handling the experiment work for few environment. Electrical circuit can be generated and measure more the accurate. Can be compiled when calculated and simulation result.